Hello, students. We are going to walk through how to construct the different key components of section 12.3. So I've got my compass and I've got the big pieces here. My straight edge will be used at times, but I'm going to go through these fairly quickly. Each one of them is going to utilize the rhombus. Remember the rhombus? It just needs something with four sides, quadrilateral. That'll make a parallelogram, and all the sides will be the same. Okay, so in order to create a parallel line, if you're given a point P, a line L, and the point is not on the line, we can build ourselves a parallel line. So here's what we're going to do. Just draw a line back from point P that touches line L. Okay. Now, use your compass to lock in the length of QP. Okay. Let's see here. Oh, that's close. Not quite. Woo! Sorry, my paper's going all over the place. I should have something here that kind of steadies it. Let's see here. Okay, there we go. See that? Goes right through. Okay. Now, with that same distance that you've already locked in, turn and touch L. It creates a new point. But again, these two are now the same length. Come over to point P and turn an angle, an arc out over here, and go down to the bottom one, turn an arc here. You have now created a rhombus. Let me demonstrate. Through this point, we construct it back. Okay. And from this point, I construct down to the one that I created on the side. And I have created a rhombus, which means that if I wanted to, and you can see all these sides are the same because they're the same length in my compass, I can simply use my straight edge now to come here and create this line. And I've got myself a parallel line. Quick and easy. Again, rhombus is the key. If you're looking for why is that so important? Because if I would create this diagonal, those angles would be congruent and therefore parallel lines. Okay, come down here. Now you have a point P, a line L, and now I want you to create something that is perpendicular to point P. So guess what? We're going to use a rhombus. I mean, the rhombus is just, it's so cool. All right, so here's what we do now. Just take your compass point and create a length that is, it just has to go down and touch the line twice. I don't care how big it is. So take your point and turn across so that we touch twice. Okay, that creates two new points. And from each point, put the pokey part in and turn. And you, when you create this new point down here and you construct between the 2 points, you will have a perpendicular line. And if you're looking for the reason why is we created a, you guessed it, a rhombus. And we created a rhombus by keeping the same length in our compass. And so when you do that with the rhombus, all four sides are the same and it becomes a parallelogram. And the diagonals are perpendicular. Boom, boom. So there it is. So again, pokey part up here, swing, that creates these two sides. Then put your point here and turn down, put your point here and turn down, and that creates the other two sides, which again are the same length. And you've got perpendicular. That's how you can build it. If you needed to prove it, remember what we did in the other proof is we created congruent triangles. And so let's just say the big triangle here on the left, big triangle here on the right. We get this angle right here. We get this angle right up here. And then we use these smaller triangles. And those are congruent by side, angle, side. And therefore, the corresponding parts have to be the same. They are congruent and supplementary. And boom, you're off and going. Next up. All right, next up, what comes next? They give you a point on the line, and they say, build a perpendicular to this. All right. So now just take your compass and again, create a length. Doesn't matter how big. All right. And turn so that you hit both sides of the line. Now, make your compass just a little bit bigger. And what we're going to do is we're going to take the pokey part here. We're going to turn up and we're going to turn down. See, I've got these two marks. That one didn't come in very clearly, did it? Let's see if I can do that one a little bit better. There we go. Okay. Next, pokey part comes to the other side, keeping the same distance locked in. And what I have, if I connected these, I would have a rhombus. But all I really need is to connect these points, and I've got myself a perpendicular line. Done. Again, diagonals of a rhombus are perpendicular to each other. Let's come down here. Let's say I gave you a segment and I said, I'd like you to bisect this segment. Oh, okay, well, that's fancy talk, Scott. But all it means is just come in here, put one pokey part down here and turn up and turn down. Come to the other side, turn up and turn down. Where those arcs meet, because these are the points of the rhombus, draw the line, and you have now cut this perfectly in half. Again, if you need to see it, go ahead and connect all the points. I'm not saying that you do need to see it. I'm just saying if you wanted to kind of visualize what we did, we built a rhombus. And by building that rhombus, we guarantee that we have diagonals that are perpendicular. We know they're perpendicular from the last one. And they have to be bisecting again because this triangle is congruent to that triangle. All right. So there we are. There's 4 of the pieces that we needed to be able to do. And let's go to the next one. I give you 3 points and I say construct a circle that goes through all of them. All right. Well, if you want to, you could build this triangle. This is one that we kind of did in class. Maybe we did it with paper folding. And you could basically say, I have this triangle. Okay. And then all I'm going to do is perpendicular bisector on 2 different sides. Because any point on a perpendicular bisector is the same distance. So I turn here and here. Now I'm turning far enough that I can later take my pokey part and put it in point C. Okay. So you see how I'm kind of just making, if you wanted to, I mean, you could make this entire circle here. There we go. Okay. Now come to A and turn. And then turn to C. Point C and turn. So what we're going to do is I'm going to connect first. So for A and B, it's these 2 points. I'm going to mark those 2 points, and then I'll just construct the perpendicular bisector. There we go. And then for points C and B, it was these 2 points. So once again, I'll just connect the perpendicular. I'll just connect these points to create the perpendicular bisector. Any point on the perpendicular bisector is the same length from the endpoints. So in particular, this new point, which I'll call N, this new point is the same distance from A and B because it's on the bisector of AB. It's also the same distance from B and C because it's on the bisector of BC. As a result, this point should be the same distance from all 3. If you want to check that, you will have to adjust your compass, but put the pokey part at N. Okay. And I made that point kind of fat, so make sure you hit the very center of it. Adjust your length. And what you'll see, my hand is in the way, sorry about that. As I make this curve, is I have created a circle right here, and it goes through C and B and A. So there is a construction. This is known as the circumscribing circle. Now, you can do this for a triangle. You might be able to do it for a quadrilateral or a pentagon. It all depends on whether or not those points all fit on a circle. For a triangle, I guarantee it always will. So this is a circumscribing circle, and this point called N is called the circumcenter. So circum, which means around, and center, which means obviously the center. So this is the center of the circle that goes around. We'll see in a moment. We have a different one when we create angle bisectors. So now we're going to construct a circle on the inside of the triangle. All right. So let's see if we can do this. I will connect the points to really show you the triangle, but I could give you any 3 points. Any 3 points here. Okay. And let's see here. So there's the any 3 points. I want a circle on the inside. That means I need a point that's the same distance from all 3 sides. In order to do that, grab my compass and mark off a little bit more than half because I'm going to make some rhombuses. Once again, shouldn't be a real shock here. And I'm going to come up to A and do the same thing. Okay. And then I'm going to come over to C. And let's see here. So I just need to come out to where the C1 intersects the A. Okay. So let's see here. I think I needed to bring this all the way over to the sides. I'm not sure why I didn't. There we go. So for the first one, for A, I come and I mark these 2 points on the sides, and then I create from that point a new point out in the middle, and from the other point, a new point out in the middle. Where those meet up, it would have created a rhombus using point A as one of the vertices. And if I connect that back, that will be the diagonal of the rhombus, which will be an angle bisector. So this angle is cut perfectly in half. Okay. I did the same thing here with B. You'll see I touched it twice, and I'm going to keep the same length. This is all about being efficient. So I go back to this point and then turn out here in the middle, and then go to the other point where B hit on the side and turn out to the middle. Again, making another rhombus. And now where this point goes back to point B, I've got another angle bisector. So what's great is any point on an angle bisector is the same distance from the sides. So any point on this angle bisector, including this magical point, which I'll call M, any point on this angle bisector is the same distance from these 2 sides. Any point on the angle bisector coming from A is the same distance from these 2 sides. So that means the point where they intersect is the same distance from all 3 sides. Now I do need one more piece here, which is I actually need to find a perpendicular because I can't just draw any old line in order to make this work. So I'm going to come here and I'm going to find perpendicular using what we already did, which is make a couple of line segments and create a perpendicular. So this, you want to get to a place where this becomes kind of old news. You give me a point and I want it perpendicular to a line. I just create those pieces and then draw that in. And the reason I need that is this length from point M to the edge has to be the length of my radius. I need it to be perpendicular then. So I grab my compass, put it at M, and I adjust my compass point until it goes through. That's a little too much. And that's a little too little. Perfect. Okay, right there. So now as I draw with my compass, the circle that I create will come in and touch all three sides exactly once. This point M is called the in center, and that's because it's the center of the inscribed circle. All right. So yes, using the properties of the rhombus, we can actually make circles that go completely inside a shape or completely around a shape, assuming that those do intersect perfectly. All right, those are the big pieces out of 12.3. So we got a chance to see how to prove those. That's what the other video was for. And this one here is how to construct them. All right, there you go. Back to you. Practice these. Again, there will be some of the constructions on the exam. Be ready for them. Off you go.